Okay, so what we're doing today is factoring and solving. We're adding a step. So pay really good attention to the factoring part so you can get it. It'll help you do your test corrections and all that stuff. So the first step is to factor out any GCF. That's what we've been doing, okay? The second step is to factor anything that's left in the polynomial. For instance, you have your GCF out here, and then you have a polynomial or a binomial, whatever. In here, you've got to see if you know how that factors. Okay? Okay. Now the new part is this right here. Set each binomial equal to 0, solve for x. That's the main things. Okay? So let me show you what I mean. So, what do we always do first? Notice it says equal to 0. That's going to become important here in a minute. Okay? What do we do first? See if there's a greatest common factor. Is there a GCF here? 2. I see a 2 and a 2 and a 24. Those are all even numbers. So they're all going to divide by 2. Okay, so do not forget your GCF. Okay, make sure you write your GCF out to the side. So what do you get? The 2's divide, and you get x squared. The 2's divide. Good, you get plus x, and then what? Minus 12. Good job. Okay, equals 0. Be real thorough. Be a good math student. Be thorough. Now, you're looking inside here, x squared plus x minus 12. Look to see, does that factor again? Okay, it doesn't start with a number right here. So that's going to be the easy kind of factoring. You don't have to do grouping on it. So we're going to say what multiplies to negative 12 that adds to 1. What are the multiples of 12? You should know these by now. We've had several problems. 3 and 4. Okay, who's going to make a 1? 3 and 4. Okay, they're going to subtract to make a 1. That was our clue right there. The sign of the last number tells us, are we going to add them, the two numbers together, or are we going to subtract them? We're going to subtract them. Okay, so 3 and 4 subtract to make a 1. That means the signs also need to be different. When you multiply two things together to get a negative, your signs have to be different. So the 3 or the 4 has to be negative to make a positive 1. Who's going to make a positive 1? Okay, the negative 3. And you can write the negative 3 here or over here. That doesn't matter. This could be a positive 4. You can switch these. Okay, I would stop right here and check them. Is negative 3 times 4 negative 12? Yes. And is 4 minus 3 a positive 1? Yes. Okay, some of y'all, if y'all would just do that really quick, all you have wrong is the signs. And you could switch the signs and save you a few points on a question. Okay, so now, if the directions say factor and that's all, you just stop. But if they say factor and solve, you've got to carry it one step farther, okay? You set all of your factors up equal to 0. There's 3 factors. 2 is a factor, x minus 3 is a factor, and x plus 4 is a factor. And you set all of your factors up equal to 0. Now, you solve, okay, for x. So you add 3. What is x? 3. It's the opposite of negative 3, isn't it? So these are easy also. Okay, you subtract 4. What is x? Negative 4. Okay, here, does 2 equal 0? No, it doesn't. So you mark it out, right? Now, we have solved. We have factored and solved. We solved for x. Now, let's talk about why factoring is important, and then the solving part, okay? This right here, up here, this x squared, tells me this is a parabola, okay? And a parabola looks somewhat, this is just me sketching one, like this. Factoring and then solving tells us where these x-intercepts are. And those are super duper important. Okay? If we turn a parabola upside down, okay, anything launched into the air, think NASA. And I'm sure NASA, it's not as easy as this, okay? But NASA has to know where everything's coming back down to Earth, don't they? They have to know where it's going to land. Absolutely, 100%, they have to know where it's going to land. Within just a few feet, probably, you know. So knowing where something is going to hit the Earth, I mean, they use math. They use parabolas. They use equations like this and solve. And, of course, then they throw in physics and all that stuff, too. But, you know, the simple version of it is, you know, it's a parabola, and they know where it lands, okay? So that's just one example. Okay, I was telling last period, and I've said this in other years, too. Think about throwing a football or a basketball. You know, sometimes a basketball's real, you know, like that, you know, if you're passing it. But, you know, football, it barely comes up, right? Wouldn't that be cool if the quarterback could go in their head and calculate, you know, where they're going to throw it, and then they would make their passes, you know, complete every time, you know. So, yeah, some of those quarterbacks out there, it looks like they're making calculations in their head as they're throwing it, doesn't it? Okay, so, okay, next one. Let's look at the next one. Let's try again. Okay, so it's set equal to 0. Okay, does it have a GCF? What is it? 3. They all divide by 3. Okay, so bring your 3 out to the side. Okay, I know we didn't use the GCF earlier, so you're thinking, oh, I don't have to write that. No, you need to write that. Okay, plus 11x plus what? 30. Okay, equals 0. I was telling, I don't know which period. First period, maybe second, I don't know. One of the things that's hurting y'all with factoring is your multiplication facts. You're kind of rusty and weak at them. Find an app on your phone, spend 5 minutes a day drilling through multiplication facts. You will be surprised how quick you get better at it. And you'll get a lot better at it. Even if you just spend 1 week. If you say, hey, for 1 week, I'm going to spend 5 minutes a day working on my multiplication facts with an app on my phone. I guarantee you're going to get way better. And you're going to be able to rattle off these factors. Like, for instance, the factors of 30. Okay, so let me back up a minute. There's not a number in here, is there? Right here. So we don't have to do grouping. Personally, you can do grouping, but I wouldn't waste my time. It's too many steps. Okay, so we're just going to say what multiplies to 30 that adds to 11. And lucky for us, these are both positive here. Okay, so what makes an 11? 5 and 6. And like I say, they're both positive, so we know they're going to be both positive here. A 5, x plus 5, and x plus 6. Just take a minute to check it. Make sure you didn't sneak in a 2 or something crazy here. Okay? 5 times 6 is 30, and 5 plus 6 is 11. Okay, so you say 3 equals 0, x plus 5 equals 0, x plus 6 equals 0. So x equals negative 5. What is x going to be here? Negative 6. It's just the opposite sign. So that'll save you a little bit of your pencil graphite also, right? Okay? Okay, so this parabola crosses the x-axis where? At negative 5 and negative 6, okay? Okay. Number, y'all got that? Okay, number 3. What do you notice different about this parabola or this equation? It's not equal to 0. We have to set it equal to 0. We have to force it to be 0. So what do we do with this 24? Yeah, just move him back over there. He's like a cow that, you know, got through a broken part of the fence, and he jumped the fence. Okay, your equal sign is the fence. Okay, negative 12x squared. Oh, and you got to get this in the right order now. What comes next? Yeah, the 44x and then minus 24 equals 0. It's x squared x and then the constant, okay, the plain number. Okay, so we got that part fixed, which is not hard to fix. Don't panic about that. Okay, now we need to look for a what? See if it has a greatest common factor. Does it have a greatest common factor? 12, 44, and 24. Okay, a 4. But, okay, don't write this down. If I divide by 4, I'm going to get a negative 3x squared there. I don't want my polynomial, my trinomial, to start out with a negative number. So this, if your trinomial starts out with a negative, make sure your GCF starts out with a negative, okay? So you don't end up, because it's harder to factor when your trinomial starts out with a negative number. All right? Okay, so now negative 12 divided by negative 4, y'all are probably ahead of me now, is what? 3x squared. Good job, minus 11x plus 6. Okay, you might be right. You might need to write a little smaller here. Don't want to take up the whole room here. Now, this time, it does start with a number. So we really are going to have to do grouping on this one. Okay? But also, guys, start using that brain you got there. What's going to make a 3? No, when you multiply, should have been more specific. When you multiply, just a 3 and a 1. You know for a fact, the only thing, if my pen would cooperate, that your answer could be is a 3x and an x. I mean, start using a little bit of logic there. Just common sense. Okay. So if you don't get a 3x and an x in your answer, then something went wrong, okay? Okay, so how do you factor by grouping? Well, it starts with a number, so you multiply the A times the C, the first times the last, you get 18. What multiplies to 18 that adds to negative 11? Okay, so we have 1 times 18, 2 times 9, and 3 times 6. 2 and 9 are going to make an 11, right? Okay, it's a positive 18. What kinds of numbers multiply to make a positive 18? You get a positive times a positive equals a positive, but a negative times a negative also equals a positive, right? Okay, so they could be a positive 18. I mean, it could be both positives, or it could be both negatives. It's a negative 11, so that means they're going to have to both be negatives. Okay, so we're going to use a negative 9 and a negative 2. That will give us a negative 11. Okay, so don't forget our little GCF out there. Okay, 3x squared. You can use the 2x or the 9x. Doesn't matter. I mean, you can put them in either order is what I'm trying to say. Sometimes it might matter a little bit, but this one doesn't matter. Oh, yeah, they're both negative. I was thinking about the order and wasn't thinking about the signs. Okay, now we group them. That's why this is called grouping. You group the first two together, you group the last two together. Now you factor out the GCF. So 3x squared and 2x, what do they have in common? Just an x, right? So you put an x down here, huh? Yeah, you could. The 9 and the 3 might divide better, and the 2 and the 6 might divide better, but it's going to work out this way also. So if you did it that way, keep going. Don't erase on account of me. Okay, so a 9 and a 6 will both divide by 3, but it's starting with a negative, so make sure your GCF is a negative. Just like up here, it started with a negative, we had to make sure our GCF was negative, right there. Okay, so now we get here, 3x squared divided by x is 3x, those kind of cancel, and we get minus 2. Here, negative 3 is our GCF. We get a 3x minus 2. Our 3x minus 2's match, so that's a good thing. Okay, and so our answer is x minus 3. Oops, forget our GCF, and 3x minus 2. Remember what we talked about a minute ago? Look, x and 3x, right? That makes it 3x squared. And then is a negative 3 times a negative 2 a positive 6? Negative 3 times negative 2, is that positive 6? Yes. Okay, we didn't really check the middle term, but we can easily check to see if at least those are right. Okay, now equals 0. I kind of dropped my equals 0 off here, didn't I? Okay, so we're going to set each one of these factors equal to 0. Negative 4 equals 0. X minus 3 equals 0. Whoops. 3x minus 2 equals 0. Negative 4 doesn't equal 0, so bam, it goes away. Yeah, x is going to be 3 because we're going to add 3 to both sides. So this one we really can't do in our heads. I'm going to teach you later kind of how to do these in your head, but not right now. We're going to add 2, and we say 3x equals 2. Divide by 3, x is 2/3. So our parabola crosses the x-axis at 3 and at 2/3. Okay. Questions about this one? So that one took a little longer because it was grouping. Some of y'all I went kind of slow on that. Some of y'all are faster, but some of y'all need to take your time on the grouping. Okay, so this one right here is a good one. First of all, we've got to set it equal to 0, don't we? So we have to do what? Subtract 98. So we get 2x squared minus 98. Now it's equal to 0. Now what's the first step? Find the greatest common factor. What is the greatest common factor? 2. Okay, bring your 2 out. You get x squared minus 49 equals 0. So this one is one of those super easy ones to factor if you will start learning to recognize the signs. Okay, the signs are that it has to be difference. Is this a difference problem? Yes, it's a minus. Difference of 2, is it 2 terms? Yes. Difference of 2 squares. Can you take the square root of both of those numbers, x squared and 49, of both of those terms? Yes. So, when I take the square root, I get x and x. So they go in the first position of your binomial. And what's the square root of 49? 7. And one's a One's a positive, one's a negative. Okay? Equals 0. So 2 equals 0. X plus 7 equals 0. And x minus 7 equals 0. So 2 equals 0 goes away. What's x? Negative 7 and positive 7. So this parabola crosses the x-axis at negative 7 and positive 7. Questions on that one? Okay. So far we've worked all the different types of factoring problems. We worked the ones that don't start with a number, where the a is 1. We started them where we did that one with grouping, and now we've done one with a difference of 2 squares. We're going to skip number 5. We're going to go to number 6. Okay? It is set to 0. That's a good thing. So what's the next step? Greatest common factor. What will they all divide by? Oh, an x also, right? Good job. Okay. In the past, on all the other problems, we didn't have an x as part of the GCF, so that's going to change things up just a tiny bit here in a minute. Okay, when we divide, we get what? X squared minus x minus 6 equals 0. Okay, are we going to factor by grouping on this one? What's right here? Yeah, basically an invisible 1, right? So we don't need to use grouping. When do you use grouping? When there's a number like a 2 or 3 or 4 kind of thing. Okay, so all we have to do on this one is say what multiplies to negative 6 that adds to negative 1. Okay, 1 times 6 and 2 times 3. Who's going to make a 1? 2 and 3 will. Okay, it's got to be a negative 6. That means the signs are going to be alike or different? They're going to be different. Yeah, different. Okay, so it could be a negative 2 or it could be a negative 3. Who's going to make a -1 when we add them? A -3, okay? So we have x minus 3, or you can say right here, you can look at this sign right here and say the larger number of the two that we just found is negative, okay? Now, you're like, whoa, by now I'm confused. Let me check it then. So you say -3 times 2. Oh, yeah, that's -6. -3 plus 2. That is -1. So yes, I got my signs right on that. I did okay. So we say 6x equals 0. We say x minus 3 equals 0. And x plus 2 equals 0. This time, we don't just mark it out. We're not saying 6 equals 0. If it were 6 equals 0, we could mark it out. But this has an x in it. So we have to divide by 6. X equals 0. Okay? There is 0 on the x-axis. There is a 0 there, right? You could have a graph crossing there, and I'll draw you a little picture here in a second. So what is x here? +3. It's the opposite sign because you're going to add 3. What is x here? What kind of a 2? -2. So this time we have 3 x-intercepts. So what's happening on something like this is, let's say this is 0. Okay, you're getting it at a 0 and a 3, and my pen's not doing good, and a -2. So something like this, possibly, who knows? But let's see if I can draw it right. So you're getting it going through -2, and then 0, and then 3. So it doesn't even look like a parabola. It didn't start with an x squared, did it? Didn't start with an x squared, so we know it's not a parabola. And you don't need to know all that. We're not doing graphs like that. I don't want you to panic. But that's how something that would look if it crossed the x-axis in 3 places. Okay? Okay, so let's see here.